My name is Colin Weaver and I'm with ITdojo, and today I'm going to show you how to launch an SSH man-in-the-middle attack using Cain. The network that I'm going to use to show you how to do this is a pretty simple and straightforward one, where I've got a victim PC connected to a switch network that has a Cisco router on it, and also connected to the network is my attacking station that's going to be running Cain. Now, most organizations use Secure Shell to provide confidentiality for the data that's traveling in between their legitimate administration workstations as over to their infrastructure equipment. The reason they do that is because they get either triple DES or AES encryption in most cases. And for a lot of organizations, it's actually been mandated by policy that Telnet's no longer acceptable for use, and you have to use SSH in order to go in and secure your data. But what we're going to do is we're going to illustrate just how easy it is to circumvent this. And we're going to create a situation where the data traveling in between these two nodes using SSH is actually being hijacked and sent over here to our attacking station, where it's then going to be decrypted, and then the data is going to be forwarded over to the legitimate device, in this case the router, and then this device is going to respond back and the data is going to go in the opposite path. The beautiful part about this is that the victim PC and the victim router think that the connection is secure, when in reality this attacking station is going to be able to see anything that it wants to in the connection that takes place. And in many cases you can actually go in and actually modify the data. So in order to get the attack started, what you need to do is open up Cain. And once you have Cain open, click over here on the sniffer tab, and under this sniffer tab, this is pretty much what you're going to see by default, is that there's nothing on the list. And what this list should contain is a list of all the available nodes that are on the network where you want to launch your attack. Now the way that you build that is, first and foremost, you go over here and you start the sniffer so that Cain can actually sniff the traffic that's coming back in. Then what you're going to do is you're going to come up here on the button bar and click on this little blue plus. Now this is going to start the MAC scanner, and you can scan either the entire subnet or you can just scan a portion of the subnet. And the other thing that you can go in and do is, under the ARP Poison Routing tab, is you need to check what kind of ARP Poison test ARP request you're going to send out. Now for the purposes of this example, all we need to do is do this 31-bit broadcast. So before I click OK on this, what I'm going to do is I'm going to come over here to Wireshark, and I'm going to start a capture where we can see the ARP request information that's coming out. So if you go to the capture drop down, choose interfaces, and then select the interface that is connected to the network that your device is on, go to options right here. And for the purposes of this demonstration, under my capture filter, I just need to receive the ARP request packets, and that's all I want to be able to actually see. So I'm going to start this capture, I'm going to let it run in the background, and I'm going to bring Cain back up, and I'm going to run this MAC scan. Now all that Cain's doing here is actually going out and sending ARP requests out into the network, and you can see in the span of about a second or two he learned all the individual nodes that are currently alive. If we come back to Wireshark, what we can see is that all Cain did was sent out one ARP request after another. Okay? And the nodes that were alive on the network responded. And when they respond, of course, they provide their MAC address information. And so this goes in and gives Cain everything that he needs to know about which nodes are currently available on the network. The IP address, the MAC address, and then from the first 24 bits of the MAC address, we're able to determine the manufacturer of the network card itself. Now we're ready to decide who on this list it is that we want to attack. For the purposes of this demonstration, again, I'm going to launch my attack against the 10.100.0.144 node and the router, which is at 10.100.0.200. And I can see right here that those two devices are indeed on my list. So to get the attack going, come down here to the ARP Poison Routing tab. And under ARP Poison Routing, what we need to do is add those two devices to this list. And the way that we add things to this list is you first left-click in that interface, or in that window, and then up here you come and click on the little blue plus. The dialog that opens up allows you to go in and choose the individual stations that you want to poison the traffic for. And you can poison the traffic for every node in the network if you wanted to, but that might generate more traffic than you're prepared for. So in this case, I'm just going to go in and poison the traffic between the 10.100.0.144 device and then the router itself over on the right hand side. So what I'm doing by saying this is that devices, traffic going from here over to here, I'm going to become a man in the middle for. And again, you could go in and selectively choose multiple stations. So I click OK. The attack is not yet running, okay? But what I'm going to do is I'm going to come down here and I'm going to start another Wireshark connection so we can actually see what it is that Cain is doing when this takes place. So now an ARP capture is running on Wireshark, and I'm going to come up here on the button bar, and I'm going to click on this little nuclear radioactive looking button, and that's actually going to start the actual poisoning. So I click on that. Now I'm actually poisoning, and as soon as I start to see packets moving back and forth right here, I'll know that the man-in-the-middle attack is now in effect. So now all the traffic that's going from the legitimate device to the router is actually going to be passing through my attacking workstation. And over here, I'm going to be able to see which kinds of traffic it is that I'm intercepting. And SSH is what we're interested in right now, and I currently don't have anything. But if I come over here to the legitimate device, the 10.100.0.144 node, and I start an SSH connection, what I'm going to do is just go ahead and log in. And you'll notice that on the Cain side of the house, we can actually now see that the traffic is being intercepted. And once I get myself logged in, I can issue a few commands and be able to see exactly what's going on with this data. So I come down here now to this ARP SSH tab, and I can see when a connection was started, when it stopped. I can also see who it was between, what its current status is, which I exited out of it, so now it's closed. I can see what the encryption algorithm that was used was, and then also I'm going to be able to see nice stuff like the username and password that was used to log in. And then perhaps the coolest thing that's available here is all the text that was sent back and forth between the legitimate clients and the router is actually just stored in the text file. So I can right click on this and I can choose view, and it goes in and it gives me a breakdown of all the connection related information. But then when I get down here, I can see the username and password that was typed in, so I can see how the user logged in, which I already saw. This is the login banner that was displayed to the user. And then I can come down here and I can see all the individual commands. And so right here, the user typed enable, and then they typed the enable secret. And so now I know what that password is. And then if we scroll down, we can see just standard router output, encrypted hashes that are right here. That's an MD5 hash, so I can go in and I can dictionary attack or brute force attack those. I can come down here, see all the individual commands that the user typed, show interface commands, view in the routing table, whatever it was that the user was doing. It's all now nice in a text file for me to go in and have. And there was absolutely no indication from the user or from the router that this was taking place. And so the beautiful part of this is just how incredibly easy it is to do. Now, at this point, the attack is still running. So if this user were to go in and start another connection, I'm still poisoning their connection. So once I want it to stop, since I've gathered all the information I really need, I've got usernames and passwords, so I'm done at this point. I'm now going to be able to go in and simply just click on this little, again, radioactive button, turn off the poisoning. That returns the connectivity back to normal, and then I just turn off the sniffer here on Cain, and now I'm completely done with my attack. That's how easy it is to go in and launch an SSH man-in-the-middle attack. For people who want to defend themselves against it, what you need to do is you need to go and make sure that either one, your routers are not using self-signed certificates, or your infrastructure equipment's not using self-signed certificates. You should have them signed by a certificate authority. Or you need to take the time to make sure that you're manually verifying the thumbprints when you're establishing SSH connections. And unfortunately, that's not the normal way that most organizations do it. Most shops go out and let their devices generate their own self-signed certificates, and users generally blindly accept those certificates when they're presented with the thumbprint when they establish their SSH connections. So it's very easy to do. You can defend yourself against it by going out and getting digitally signed certificates. And just know that somebody can launch this against you really quickly. Again, if you want to see this video again, you can go to my website, www.itdojo.com, where you can get a copy of this video. Plus, there's also other security-related articles on the site for you to have a look at. So again, this is Colin Weaver from ITdojo. Thank you very much.